So there are things called natural climate solutions or nature-based solutions, and there are some good papers on it as well. I want to go through this briefly through this report from McKinsey and World Economic Forum, which wrote this report in January of last year, called Nature and Net Zero, which touches on nature-based solutions and their role in contributing to net zero, which is now very critical that we seek all possible avenues to bring ourselves to net zero. So the demand for natural climate solution credits has increased over the past 10 years. So more and more corporations, communities and governments are going after natural climate solutions. So here are the numbers going from 2010 to 2020 in terms of percentage proportion of NCSs of the total credits retired. So voluntary carbon credits retired by project type in million tons of CO2 equivalent, which include chemical processes, industrial manufacturing, waste disposal, energy efficiency and fuel switching, renewable energy, household devices, and transport. So those are the main bluish colors. And as for natural climate solutions, they are based on agriculture, so ways in which you reduce agricultural emissions and also drive additional carbon sequestration into soil and so on. Forestry and land use, the same thing. You reduce emissions from deforestation, forest degradation, land use change, and ARR is let me find out. Oh, I should have looked. Sorry, I blanked out on that one. I should have known on it. Known that ARR. ARR is afforestation, restoration and rejuvenation and other, and forestry and land use conservation, which was the basis for RED under UNFCCC, reduced emissions from deforestation and forest degradation. So the main point is that more and more credits are being sought for implementing nature-based climate solutions as a way to reduce emissions, and this is a 1.5 degree pathway that will require 23 gigatons CO2 net emission reduction by 2030, as we already saw in terms of the ambition gap to 2030 compared to where we are headed. This is now compared to 2019 level. So net carbon dioxide emissions over time. So here is 2010, 2016, 2019 and 2021 going out to 2050. So net carbon dioxide emissions in 2010 were 39 gigatons CO2 and then over 2016 to 2019 it has hovered around 41 gigatons CO2. Remember, this is not CO2 equivalent, this is just CO2. So if you go to 2030, net emissions reduction by 2030 versus the 2019 levels, which are here, is 23 gigatons CO2. And as you go into the future, a 1.5 degree pathway requires 23 gigatons CO2 by 2030. NCSs can contribute to this net emission reduction through avoidance and reduction, so avoided deforestation, removal and sequestration, so reforestation. As there are multiple climate mitigation pathways, there could have been even larger role for NCS in delivering a 1.5 degree C pathway than that shown by the pathway here. So you can see that the NCS can contribute to this net emission reduction through removal and sequestration, increasing in its contribution by 2050 to almost 5 gigaton. So you are basically compensating for what is being emitted through other human activities. So again, net zero means you are taking out more than you are emitting, and not that you are not emitting at all. Okay, so NCS could deliver up to 1/3 of net emissions reduction required by 2030. which is 23 gigatons compared to 2019, as we said. Total NCS abatement potential out of net emissions reduction required by 2030. So you have 7 from NCSs out of the 23, so almost 1/3. Abatement potential per NCS per year by 2030, so that's the total, which is about this. And then avoided deforestation and peatlands, so you have forests, wetlands and croplands. Total before economic feasibility filter applied to reach practical potential is 5.3 gigatons. So there is the actual potential and practical potential, just including various barriers to implementing natural climate solutions. So avoidance is 60% and restoration is 40%. So avoided coastal impacts, peatland restoration, reforestation, cover crops, trees in croplands and coastal restoration. So you have peatland restoration and coastal restoration, especially mangrove forests and other subaquatic vegetations which have a high potential for sequestering carbon as well. So this gives you a sense that if we are diligent, low-cost NCS potential can be found everywhere across the globe, with the bulk of the volume in the global south, which is very critical because either they can be incentivized to implement them or they can implement them for their own benefits. So incentivizing means could be offsetting till offsetting is eliminated so that rich countries can emit some carbon and pay for NCS in the global south, which generally offsetting raises lots of flags, but so be it. So percentage share of NCS potential is shown. What is represented on the map is lower cost NCS potential, high, medium and feasibility. Countries with a share of NCS potential that is 1% or greater. So you can see Brazil has 15% with Amazon restoration activities, obviously. Democratic Republic of the Congo has similar rainforests. India here has about 2%. Myanmar 15%. In Indonesia, again relating to coastal and forest restoration. Papua New Guinea, Australia and so on. So while bulk of the low-cost supply is in global south, this does not devalue actions in the global north. So they can continue to contribute since historically they are the major emitters. Just to look quickly at the environmental co-benefits of natural climate solutions in addition to additional carbon sequestration, in each case, so avoided deforestation, reforestation, avoided peatland impact and peatland restoration. You look at avoided and sequestered carbon, biodiversity, soil health, and there is a grading given to the each benefit, so high, medium and low. So I won't read through all of them, but you can get the report and look it up. But always good to have co-benefits which enhance the possibility of practical contributions towards a net zero, which may not be always accessible because of the barriers, as we said. We also have water quality, so cover crops, trees in croplands, avoided coastal impact and coastal restoration. So same categories here: avoid, sequester carbon, so avoid emission or sequester additional carbon. Biodiversity, low probabilities. Soil health, medium. Water quality, medium. So this is the so-called agroforestry, which has other benefits like drought resilience, soil moisture persistence, groundwater recharge, non-rainy season incomes. In fact, even helps family units by reducing migration of rain-fed agriculturists, farmers going off seeking labor elsewhere, which tends to create lots of other problems and so on and so forth. Okay, so the report identifies 6 key actions needed to unlock natural climate solutions. So we can start anywhere. Define net zero and corporate claims. So we already looked at attributes of net zero and meaning of net zero in the previous podcast. So that still is part of this story. Highlight good practices for supply. So companies like Apple, for example, have realized that they cannot just worry about what they are directly manufacturing or producing in terms of software, data storage, etc. But they also have to worry about the supply chain which is supporting their product. So they have to look for net zero throughout the life cycle end to end of an iPhone or other product they manufacture. So highlighting good practice for supply is critical. Send a demand signal so that the outsourcing, for example, if Apple is wanting to produce something in China, it can send a signal for demanding natural climate solutions as part of their manufacturing process, etc. It could be done as an offset, or it could directly rely on natural climate solutions during mining for material and so on and so forth. Improve market architecture so that natural climate solutions get a fair share in the market as opposed to fast, irreversible junk production that mostly happens. Create regulatory clarity within the country and across international borders so that embedded carbon can also be tracked and build trust. Of course, that's always an important feature. So this is just a very brief introduction to argue that net zero, which is now becoming more and more common in terms of countries committing to net zero and giving a date that's multiple decades out. But how do we get there? All these nature-based climate solutions, especially like afforestation, restoration and rejuvenation, for example, or wetland and peatland restorations, etc., take time. So if we start now, then by 2050 they can begin to really kick in terms of their contribution to net zero. I have podcasts on natural climate solutions in other courses as well that you can look up, but this was particularly in the context of net zero, so I've done it here very briefly, but you can learn more about the various ways in which nature-based climate solutions or natural climate solutions work and how they can be implemented, what are the barriers, etc. Okay.